Hello, my name is Tiffany Doe, and today I will be introducing the synthesis of isocyanide and phosphine complexes supported by fluorinated tris-pyridyl borates. Polypyrazolyl borate ligands were first synthesized during the 1960s. They are known as scorpionate ligands. Scientists have found many applications using this ligand as in coordination chemistry, biomimetic chemistry, serving as catalysts and for development of new materials. Polypyrazolyl borates have some properties that we can improve, such as the BN linkages, and have only three substituents on the pyrazolyl group. Therefore, my group wants to develop new materials that can offer some better properties than the pyrazolyl borate. That gives us motivation for the synthesis of polypyridyl borates. These new ligand systems offer different advantages. For example, the more robust BC linkages compared with BN linkages. Four substituable positions on the pyridyl group versus three substituable positions on the pyrazolyl group. Proximity of the six substituents to the metal centers for enhanced metal protection. And this new ligand are believed to be better sigma donors. Another aspect in my lab is the use of fluorinated ligands because CF3 groups can offer some significant properties such as thermal and oxidative stability, as well as their unique reactivity. Combining the properties of pyridyl borates and fluorinated groups, we endeavor to synthesize the fluorinated polypyridyl borates ligands for metal complexes. The potassium salt has been synthesized in 3 steps, starting the bromopyridine in high yields, and will serve as starting reagents for the upcoming reaction. Isocyanide complexes were chosen for the study not only because of their importance in biological activities, but also the C triple bond end stretching could serve as a gauge of ligand electronic effects on the metal sites. The potassium salt reacts with copper, gold, and silver in the presence of tert-butyl isocyanide, gave the corresponding copper, silver, and gold isocyanide complexes. These complexes were characterized by many methods using IR and X-rays crystallography. These three structures are the 3D structures of those complexes obtained by X-ray. The IR frequency of those complexes show the increase in CN stretching frequency compared with the free isocyanide, with gold complex having the highest stretching frequency and copper complex having the lowest frequency in this series. It indicates the very strong sigma donating of the isocyanide to the metal complexes and the very weak pi back bonding effects from the metals to the isocyanide moiety. Phosphine complexes are also very particularly interesting due to the application in anti-cancer. The NMR of these complexes are also very useful for academic studies, using the similar methods to isocyanide, but instead using triphenylphosphine. We obtain 3 phosphine complexes as shown here. The fluorine and phosphorus NMR of these complexes are interesting since they show the coupling between fluorine and phosphorus. For example, in copper and gold complexes, the coupling between fluorine and phosphorus shows a doublet in fluorine NMR. In the case of silver complex, the fluorine also couples with silver. That is the reason we obtain a doublet of doublet in the fluorine NMR of the silver complex. In phosphorus NMR, the spectrum of silver complexes show the coupling between phosphorus with fluorine along with 2 isotopes of silver, which is silver 107 and silver 109. In conclusion, tris-pyridyl borate is a new class of scorpionate family and potentially show unique properties in the future results. Thank you.